Have you ever looked up at a giant airplane and wondered how something weighing hundreds of tons can soar effortlessly through the sky? It might seem like magic, but every flight is actually a remarkable combination of science, engineering, and the laws of physics working together. Before we understand how an airplane flies, let's take a quick tour of its major parts: the cockpit, the nose, the wings, the engines, the tail, and the landing gear. Each component has a specific job that makes flight possible. Every airplane in the sky is constantly influenced by four powerful forces: lift pushing upward, weight pulling downward, thrust driving it forward, and drag resisting its motion. Understanding these four forces is the key to understanding flight. Let's begin with lift, the upward force that allows an airplane to leave the ground and stay in the air. Working against lift is gravity. Gravity constantly pulls the airplane toward the earth, creating the force we call weight. To overcome this, the engines generate thrust, pushing the airplane forward at incredible speed. As the airplane moves through the atmosphere, it encounters air resistance. This opposing force is known as drag, and it constantly tries to slow the aircraft down. When lift balances weight and thrust balances drag, the airplane achieves stable, smooth flight. The real secret to flight lies in the unique shape of the wings, known as an airfoil. As the airplane moves forward, air naturally flows over the top of the wing and underneath it at the same time. Here's where Bernoulli's principle helps explain what happens. As air moves faster over the curved upper surface of the wing, its pressure decreases. Meanwhile, the slow-moving air beneath the wing creates higher pressure. This difference in pressure is one of the key reasons an airplane can fly. The higher pressure below the wing pushes upward against the lower pressure above, creating the lifting force that carries the airplane into the sky. Now let's see how the engines create thrust. A modern jet engine consists of 5 main sections: the fan, the compressor, the combustion chamber, the turbine, and the exhaust nozzle. The process begins as the large front fan draws enormous amounts of air into the engine. Inside the engine, the air is compressed, mixed with fuel, and ignited inside the combustion chamber, producing an intense release of energy. The hot, expanding gases rush out through the exhaust at extremely high speed. According to Newton's third law of motion, this backward blast pushes the airplane forward with tremendous thrust. With maximum engine power, the airplane accelerates rapidly down the runway, increasing from a standstill to nearly 300 km per hour in just a matter of seconds. As its speed increases, the wings generate more and more lift until the upward force becomes greater than the airplane's weight. Gradually, the nose begins to rise. Moments later, the main wheels leave the runway, and the airplane is officially airborne. After takeoff, the landing gear retracts neatly into the aircraft. This reduces drag, improves aerodynamics, and helps conserve fuel during flight. The airplane continues climbing steadily until it reaches its assigned cruising altitude. At cruising altitude, the air is thinner, creating less resistance. This allows the aircraft to travel faster and more efficiently while using less fuel. Flaps are movable sections located along the trailing edge of the wings. During takeoff and landing, they increase lift, allowing the airplane to fly safely at slower speeds. Near the tips of the wings are the ailerons. They move in opposite directions, causing the airplane to roll, making smooth and controlled turns possible. Mounted on the vertical tail is the rudder. It controls side-to-side movement, known as yaw, helping keep the airplane stable and properly aligned. Attached to the horizontal tail are the elevators. By moving up or down, they control the airplane's pitch, allowing it to climb or descend. Inside the cockpit, pilots constantly monitor dozens of flight instruments while using these control surfaces to safely guide the aircraft from departure to destination. As the journey comes to an end, the airplane gradually begins its descent toward the destination airport. Before landing, the landing gear extends and locks firmly into place, preparing the aircraft for touchdown. The airplane gently touches down on the runway, with the main landing gear making contact first, followed by the nose wheel. After touchdown, reverse thrust redirects the engine's airflow forward, while powerful wheel brakes slow the aircraft safely to a complete stop. Every successful flight depends on the perfect balance of four fundamental forces: lift opposing weight and thrust overcoming drag. The next time you see an airplane soaring high above, you'll know it isn't magic. It's the incredible result of science keeping us flying.